Now case number third. This is figure. Remember, this is a part of this mass. X is a part of L. Length of this mass is this much and X is this much. Then just we will subtract this X from L. We will get this part, empty part. Now try to understand. Force for this figure will be our F is equal to ma, which is the first equation, and force this second figure will be our F minus T, which is equal to ma. Over here we know value of F. So this will be ma minus T, which is equal to ma. So minus T, ma minus ma. So T will be ma plus ma. Clear? Remember, it is a m1, this m2, m1, m2, m1, m2. T is equal to is a common m1 plus m2. To calculate isolation, we have simple A is equal to T upon m1 plus m2. This is for this. Okay. Here we will get A. To calculate the tension, we have T is equal to A multiple total mass. A multiple total mass. A is equal to F upon T. Or there is another method. There is another method. Just find value of over here, which is equal to A m1 plus m2. This is the equation of m1, first equation. That's second equation. Just put value of T. Just understand, to calculate A, you have F upon A, net external force upon net force. Your T will be F minus M into F upon M. F upon M. This is your tension. To calculate length mass of a rod. This was our rod. Length mass of rod will be our M. So one length mass of rod should be how much? M upon L. Should be how much? M upon L. Okay. So X length, to calculate X length of rod would be how much? Just we will multiply this X by M upon L. X, clear? We will get our M. T is known as F minus M upon L multiple into X, then into F upon M, which is equal to T is equal to F1 minus X upon L. This is our equation. Try to understand. This was rod, and it is just a part of this complete rod. Here for this F is equal to ma. For this we have F minus T is equal to m2 into A. So T was F minus, and over here a value of A is how much? F upon M. Just we substituted value of A over here, so that we can get tension. Force. So F minus M into F upon M. Length mass of rod. To calculate length of this mass rod, we know M. and this is m. So there is a one length of mass of rod. Just we will divide m upon length. What will be mass of the rod? For example, 10 and length is 2. We will get our one length. Okay, one length. X length mass of rod. Just we will multiply this x by m upon l, which will be our a small m. This a small m. To calculate mass of this part rod, we have this formula m upon l. Big mass upon length, complete length, multiple x, we will get a small mass. Okay, tension for this, we have T is equal to F multiple F minus m upon L into x. So this F minus m into so over here value of m is m upon L into x. This is value of m. Then multiple f upon m. Just in this equation we substitute value of m. That's it. Value of m in this equation. Okay. Everything is same. Just this value of m became this much. M upon L multiple x. Okay. Then we saw that f was common. 1 minus and over here m is cut into each other here. So x upon L. This is our final equation. This was our final equation to calculate tension force for this part rod. Okay, for this part rod. To calculate length, we have this formula m upon L into x, which is equal to m. Now let's take equation. First question is based on third case. Find out the value of tension T. Figure is this rod T inside it. Remember, this string is not massless. It has a mass, massive mass, not a small mass. Okay. So for tension force for this massive string will be how much? This is what question is asking. Where length of this rod is a 9 meter. Okay, this is a length, and force is how much? 18 Newton. And this part, only this part from here, this part is a 3 meter. Clear? 3 meter. So just it is asking tension. So for tension we have a equation. T is equal to F minus value of m was m upon L into x into F upon m, which is the value of a. Okay. So tension force A, which will be equal to F1 minus x upon L. Yeah. For example, T is equal to F, yeah, minus m. M is m upon L multiple x into x. Then F upon m again m, which is m. This will cut to each other. F is a common. F 1 minus x upon m. This is what we wrote over here. This is what we wrote over here to calculate tension force. Okay. You have already F, which is 80 Newton, and L is 9 meter. You don't have mass, yeah? You don't have mass. 3m is a x. Value of x is how much? 3m, which is a part of L. X is a part of L. We will not care about mass because in this equation there is a no m. So to calculate a t, f is a 18. One will be as it, x is a 3, L is a 9. That's it. So 18, 9 minus 3. 3. T will be 18 multiple 6 upon 9. 9 to the 18. T is over here, 6 to the 12. 12 Newton is for tension force. This is our answer, final answer. Just we used this tension equation to calculate tension force for this massive steel. It was providing F, L, X, that's it. And just we applied all these values in this equation and we got a tension force for this massive steel which came out as a 12 Newton. 12 Newton. Now let's move on the case number 4th. Case number 4th. Case number 4th. Case number 4th is if all the bodies are in equilibrium, therefore net force on each body is zero. Figure is something like this. This is figure M2, M2, M1, T1, T2. T1, T2. Yeah, let's make a FBD, figure body diagram, so that we can have all forces. Clear? FBD for first M1, FBD for second M2. Over here, it has a MZ. Yeah, it has a MZ. Clear? Can we write MZ is equal to T2? Yeah. Same thing can be written as T1 is equal to MZ plus T2. Am I right? Yeah. There are two forces, T2 and MZ, two forces. If all the bodies are in equilibrium, means velocity is constant and bodies are in rest. Therefore net force, if external net force on each body will be how much? two equation we got, two equation we have got, two equation. T is equal to M2 MC. Now our work is to substitute the value of T2 in this equation. We will get value for T1. So can you say T2 is equal to M2Z? So T1 is M1Z plus M2Z. Yeah. So T1 is coming out as a Z is a common, M1 plus M2. This will be our T1. This will be our T1. Clear? T1. Here we know that this upward force will be equal to downward force, where acceleration is 0. 0. It is the meaning of equilibrium. Acceleration is 0, velocity is constant, bodies are inflated. So over here what is happening? We can write mg minus T2 is equal to 0. Acceleration is 0. So T2 over here it came, this T2 is equal to M2 into Z, and T1 is equal to all the forces that are downward and T1 is upward. So downward is what? T2 plus mc. Okay, this equation we will use when bodies are in equilibrium. Okay, so next external force T1 will be this much and T2 will be this much. That's it. Now case number 5th. Case number 5th. Over here, case number 5th. Figure is something like this. Body M2, M1, acceleration is upward, F is upward, acting force is upward. Okay, there will be T, tension force. Yeah, this is our figure. Now tell me, mc will be downward. Yeah, so mc is going to be equal to T, and F is going to be equal to T plus mc. Am I correct? Am I correct? Yeah. What if I say this is wrong? Why? Reason is, now bodies are not in equilibrium. Acceleration is not equal to 0. That's why this equation will not exist for this figure. Okay? Reason is there is acceleration. So for acceleration, we have what? For acceleration, we have something else, which is F. This F minus upward force, downward force. So F minus T plus, and this M1 Z is equal to MA, means total mass into acceleration. So total mass M1 into A. For over here, this will be our T, and this will be T plus M1 Z. T plus M1 Z. F is equal to T plus M1 Z. Now for second body, we have T, this T minus mg, T plus m1g. Here force is, here tension is how much? This is T and this plus mg for this system. Now T minus over here force is mg. So T minus mg is equal to ma. So second body, we have now second body m2a. Okay, m2a. This will not be equal to 0. Reason is there is acceleration. There is a acceleration. So this is one equation and this is second equation. Second equation. What is happening over here? F minus, we are getting a value F minus m1 plus m2 into z, which is equal to m1 plus m2 into a. This equation we are getting F minus, let me erase this part over here. Over here. This T will T plus and T minus will cut to each other. F minus and over here M1 and M2 both are different. So J is a constant. J is a constant. M1 and this minus will become positive. So minus is over here. So M1 plus M2. M1 plus M2 into Z is equal to, over here A is a constant. So M1 plus M2. Just we are adding over here. So M1 plus M2 and A is a constant. A is a constant. We can calculate acceleration. So acceleration will be F minus M1 plus M2 into Z upon M1 plus M2. Okay, which is equal to A. So what is happening over here? This F and total mass minus total mass. F total mass M1 plus M2 into Z, because Z is a constant for both bodies. J is a constant. So upward force minus downward force with a mass. So M1 plus M2 into Z is equal to total mass into acceleration. Ma. So bodies are 2. So that's why M1 plus M2. What is happening over here? Final force minus inertial force, or you can say upward force minus downward force is equal to Ma. So there are two bodies, M1 plus M2. That's it. It is happening. Okay. F minus mg. F minus mg. F minus mg. So M is what? M1 plus M2 into Z upon total mass. So total mass is M1 plus M2 is equal to acceleration. This equation 4. This equation is for where acceleration is a something. Okay, acceleration is not 0. Then this equation will be there are two bodies. How much? Two bodies. And two bodies are moving with some acceleration. Okay, bodies are moving. This equation we will use. Okay, acceleration. Now T will be equal to M2 G plus A. Try to understand. G plus A. We are talking about this T. So M2, this M2 is a mass, Z is a downward and A is a upward. So Z plus A. Both are, if you see, both are Z. Okay, both are acceleration Z. So that's why both will be added. M into Z. M into Z. So M2 this and Z will be for both. So to calculate the T, we have M2 multiple Z plus E. And for M we have nothing but for in m1 into t1 plus m1 into g plus a. Here total mass and total g plus a, because a is upward and g is downward. Both are acceleration. Okay, total mass multiple total gravitational force, g plus a. Here acceleration is not zero. Remember, acceleration is not zero. That's why this both three equation will exist. Three equation will exist. Now next case is, in this case body was going upward. Now next case is body will be going downward. In that case, what will be our equation to calculate tension, force and acceleration? Okay, acceleration. Now let's see next case. Next. Case number 6. Body is accelerating. Body is accelerating vertically. Downwards. Figure is there is a force upward m1 m2. F now see over. Body is accelerating vertically downward. Means bodies are coming downward. Over here, this will tension over here will be how much? T plus this is T plus m2z. Okay, so m2z. Here this will be equal to this T, which is T plus m2z. Now you can finally write F minus T plus here this will be minus mz. Okay, mz, which is equal to ma. So m1 into a. This is our equation. But this is going downward. So first will be our T plus downward. So T plus m2z Am I correct? Yeah. Which is equal to minus f m1 into a. Okay, into a. This first and upward, f downward minus upward, acceleration is a downward. Now over here we will get f as a m1 a minus a plus m2 into z. For this body over here t is how much? M2 z. For this body we have this is t m2 z minus t, which is equal to ma. So m is what? m2 a. Clear? Here we can't write that the t is equal to m2 z. No. Reason is body is accelerating. We can't write that t is equal to m2 z. We can't even write f is equal to this t. No, not at all. Reason is a is not equal to 0. A is not equal to 0. Acceleration will become t plus m2z minus f upon m1. Remember downward force. So t plus m2z minus upward force. So upward force is f. Upward force is f. This is a t and plus m2z. T plus m2z minus upward force plus m2. There are two bodies. Net total bodies. m1 plus m2. There are how much bodies? Two bodies. For f, to calculate f, we have m1 plus m2 g minus a. Minus is for negative direction. Direction is a downward. Okay, minus is for negative. Total mass m2 gravitational force. Now for tension, for T, we have simple m2 and total gravitational force, which is z minus a. Total gravitational force, which is z minus a. Okay, this was our equation. m2 for this T, over here T will be what, and over here F will be what. Again I am telling you, F will not be equal to T plus m2z. No, F will be equal to total mass m1 plus m2 into z minus a. And for this T will be equal to not m2z. No, T will be equal to this mass multiple total gravitational force. So not a total. Here bodies are going downward. That's why g minus a. Okay, g minus a. Minus is for downward. Clear? Okay. Here even you can say f net upon total mass. Clear? Same thing we are getting, total mass. And over here m multiple a. Total mass multiple total acceleration. G minus a. Next cases are over. Now next we have question. Now I am going to take a question based on this concept that we have seen. First is 2 kg body. Three kg body. F is 20 Newton. Acceleration is in this direction. This is our first question. Question is asking, in the following figures, find out acceleration and tension, normal force. Tension or normal force. So what will be our acceleration and normal force, or we can say tension force. Okay, this is tension. It is also normal force. Here, there is acceleration, yeah, acceleration. That's why we can't say that the T will be equal to F. No, not at all. Not at all. So it is asking acceleration. Can you say acceleration will be equal to net external force? Yeah, net external force. So net external force is how much? Acceleration is not given, yeah. Acceleration is not given. So that's why acceleration is not given. Over here, T will be for first T will be equal to mg. So m is how much? M is 2 and z will be z. mg. ma, not z, okay, ma, 2a. For this first object, T is equal to 2a. Can we write? Yeah, we can write. For second body, this is first equation, remember. Don't worry, we are finding acceleration, okay? Just have a passion. See, for second body, F will be equal to, but remember, there is also a tension force. So acceleration is in this direction. This F minus T, okay? F minus T will be equal to ma. So m is 3, a is not given as a number. F is 20, T is 2a, which is equal to T is 2a. Yeah. Now over here we will get value of a. 20, 3a plus 2a. 20 upon 5, which will be equal to 4. Am I correct? So a is 4 meter per second raised to power 2. This is what question was asking. Now it's a time of a tension. Yeah, from this equation we can find. So F is 20. Here T is 2a. So A is 4. So T is coming out of 4 to 8 Newton. Tension force over here is 8 Newton, and these two bodies are moving with 4 meter per second raised to power 2. Okay. So T is how much? 8 Newton, and A is 4 meter per second raised to power 2. That's it. Now second question. Let me this. This is done, okay? Now next question. First of all, draw a FBD, free body diagram, one by one object, one by one body. Then see what is F is equal to, then see what is T is equal to. You will get two equations. By the help of those two equations, you will get value of A, value of T, value of F. So second question is, there are two bodies. There are how much? Two bodies. One small body and one big body. mass is 2 kg and 4 kg. Acceleration, direction of acceleration is forward, and 20, not a 20 but 42 Newton. 42 Newton force are acting on the objects, on the bodies. 42 Newton. Okay. For first body we have F is equal to F, which is 42 Newton. So F2, and normal force will be how much? 4 multiple A. 4 multiple A. M into A. So A is not given. That is what question is asking. A is not given. Can you write 42 minus N is equal to 2A? Yeah. Over here, let's say that this is the first equation. For second body, there is no force in this forward. There is no force, but backward, 40 Newton, and minus this N is equal to 4A. Second equation. Am I correct? Can you write over here normal reaction from this body will be how much? N1, let's say, will be 4A. And this was just put a value of 4A. Okay, 4A in this equation. So 42 minus 4A is equal to 2A. 42 is equal to 2A plus 4A. 42 upon 6. A came out as a 7 meter per second raised to power 2. N would be how much? 42 M is N1 A is 4 multiple 7. So N which is a tension 28 Newton. A is a 7. And A is a 7 and normal reaction is a 28 Newton. That's it. This is our answer. Now see what did we do? We did just this force minus N of second body. So this F2 minus N, which is equal to MA. M is to A for second body. This complete force minus I think erase this part here. Yeah? 42 minus normal it is equal to 4A. So N is how much? Normal reaction from here we have 4A. 42 minus 4A is equal to 2A. So just erase this part. It is not making sense. Okay. So N1 we know that normal will be equal to M multiple A. M is a 4 multiple A. And just we substituted value of N over in this equation, and this equation gave us what value of A, and then we put value of A in N is equal to 4, and we got the normal reaction as a 28 Newton. That's it. Okay, third question. In the first question there was one body, in this question there are two bodies, and in the third question there will be three bodies. So it is happening so that we can get more clarity. more clarity. So next there are three bodies: 2 kg, 3 kg, 4 kg, 4 kg, and acting forces 45 Newton. 45 Newton. One by one, we will get FBD, free body diagram, for each bodies. For each bodies. Okay. Now, for first, we know 45 is here. 45. 45 minus acceleration is in this direction, acceleration is in this line, minus this 4a plus 3a will be how much? 7. Just see. F is a 45, and n will be how much? N will be for this will be n into a, so 2a, yeah, n1 will be 2a. This n1 and n2, clear? So I think here it should be 3, it should be 3. So 45 minus 3a is equal to 45 minus just write acceleration would be total force. So total force is how much? 45. In this there is no force. Total mass is 2 plus 3 plus 4. 45 upon 3 to 5, 9. So 5 meter per second raised to power. That is how you can bring answer. Now what would be N2? Acceleration is for each body. So N2 would be how much? This N2. N2 is equal to 4a. N2 is equal to 4a. So a is nothing but 5. This will be our 20 meter raised 20 Newton. And N1 is how much? 3a. N1 is a 3a. So 5 3s are. Remember in this side forward there is no force, but when it comes to secant body, here is a 45 and in this N2, so 45 minus N2 will give us N1. So 45, N2 is a 20 Newton, and N1, which is coming out as a 15 Newton, not 15 but 25. N1, is it correct? N1 is a 35. N1 is 35. So over here 3 5s are 35. 3 5s are 15. N1 is 3 5s are 15. 15. 15. So 45 minus N1 is equal to, in this direction, 4 multiple 5 20. 20. 45 minus N1 is equal to 2A. Try to understand. 45, this force opposite N1. N1 is from second body, N2 is from third body. So this F minus N1 is equal to MA. M is 2. Now 45 is equal to 45 value है N. So minus N1 2 multiple 5. 45 minus N1 is equal to 10. N1 is equal to 45 minus 10, which is equal to 35. This is our answer, Newton. Okay, this is our answer, Newton. Enough. Remember, N1 was from was present inside second body. N2 is inside third body. Okay, so this 45 minus N1 is equal to MA. Next topic. Lift problem. Effective G or apparent weight of a man in lift. When it comes to lift problem, okay, lift problem based question, then weight of man in a lift, effective weight, okay, effective weight of a man in lift would be what? Effective weight, which means W is equal to mg will be how much for a man who is inside lift. Then remember, weight is equal to mc. So case number 1 is, if the lift is at rest, okay, if the lift is at rest or moving uniformly, means uniformly means acceleration is 0, velocity is constant, then weight of man in lift would be. So let's say this is a figure of lift, and there is a person inside it. This is a lift. Remember, this is a lift. Question is asking, it's not question but case, condition. If lift is in a rest or moving with constant velocity, then weight of man. Here, normal reaction would be upward. Mc will be downward. You would say, if acceleration is 0, then N will be equal to mc, or W will be equal to mc. but acceleration is not equal to 0. In that case, normal reaction will not be equal to mg. Remember, here n is equal to mc. Reason is a is 0. Okay, acceleration is 0. Clear? Acceleration is 0. You are getting actual weight of a man. But when it comes to acceleration, then you will not get actual weight. It will depend on acceleration. So this was the first case. Next case is case number second. If the lift is accelerating upward, then what would be weight of a man? Okay. Now remember, I am talking about this is second number case. In that case, let's say acceleration is upward. Acceleration is upward. It means lift is going upward. Lift is going upward with some acceleration. In that case, we know net external force is equal to m. M is let's say mass of is it a mass of man or lift? Let's see. So over here, reaction would be upward, and gravitational force or weight force will be downward. Acceleration is upward, so this n minus mc. So n minus mc will be equal to ma. Remember, we have two acceleration. A is upward and Z is a downward. A is upward, Z is a downward. So this equation will become m is equal to ma plus mz. You can see Z is a downward, A is a upward. There are two acceleration. Okay. So this equation can be written as n is equal to ma plus mz. Over here, m is a constant. A plus z. Final equation will be n is equal to m into a plus z. This is valid when lift is going upward. Okay, this equation is valid when lift is going upward. When lift is going downward, then here we will replace this positive sign by negative. Okay, for a downward direction. Over here, we will get effective weight more. Okay, effective weight, not actual weight. We are talking about weight of a man, not mass. Now next case is remember over here we will get apparent weight. Okay, apparent weight more than actual weight. Okay, than actual weight. Isn't it? It is going upward. At rest or velocity is constant, then we will get actual weight of a body. When object is upward and that object is coming downward, then actual weight will be coming more. Clear? So case number third is lift is coming downward. Lift is accelerating downward. Then what would be our normal? In that case, let's say now it is like this. So mg, first force will be direction of a first force will be same as direction of acceleration. So over here direction of acceleration is in this direction, so mz is this will be, we will take this mz. So mz minus n, mz minus n will be equal to ma. M is equal to ma minus mz. Ma minus a. Here m is constant, m is common, a minus z. Just you can see, we just replaced this positive sign by negative. That's it. Everything is same. Just this was replaced. Positive sign was replaced by negative. That's it. Okay, this equation will be used when left is coming downward. When left is accelerating downward. If left is accelerating upward, then our normal reaction will be m into a plus z. M into m plus z. M multiple total acceleration. Clear? Just say positive is for upward, negative is for downward. That's it. There is no difference. Except direction. Except direction. Now for this, we will get more actual weight force. Apparent. More actual weight. Okay, more actual weight. Because lift is going downward. Now case number 4. Now, if there is a free gravity space, there is no gravity, no gravitational force, then remember A will be minus G, means both A will be 0, A will be Z, A will be Z. So G minus Z will become 0, M multiple 0 will become, normal reaction would be 0. Normal reaction would be 0, means there is no gravitational force. Okay. If remember, if the lift is falling freely, then our A will be 0. Reason is there is no air resistance. In that case, A will be equal to Z, means gravitational force will be acceleration will be how much? Acceleration will be equal to Z. Okay, acceleration will be equal to 0. So finally we will get n equal to 0, means upward force, normal reaction will be equal to 0. Reason is there is no air resistance. That's all. Air resistance. So A will be 0, normal force will be 0. M into 0 will be 0. If A is more than Z, value of Z is what? 10. But sometimes we can have a value of A more than Z. In that case, if A is more than Z, okay, if value of A is more than 10, in that case, then man will move up with respect to, then man will move up with respect to the lift, means man will also move with lift. If lift is moving, then man will also move. Lift is going like this, so man will be also going. If acceleration is more than Z. Okay, if acceleration is more than Z. This was the third case. Now, fourth case. Case number 4. if the lift is retarding means acceleration is negative, retarding upwards, then what will happen? Retardation is upward. Try to understand. A is negative, this lift is going upward, but acceleration is downward. Lift is going upward, but acceleration is downward. In that case, so this will be mg, but remember, direction of lift, if a direction of lift is upward, then upward force will be taken firstly. So n minus mg will be equal to n. Okay, m. But here, when it comes to retardation, we take a as a minus a. Okay? m minus a. Okay, m minus a. Now let's simplify this equation. N will be equal to m minus a. This minus will become positive mg. Over here we have m a minus mg. M is a constant, a minus a, but minus over here m is a constant, so g minus a, am I correct? G minus a is a negative, j is not negative, so finally we have this equation, n is equal to m. So here minus is for retardation, clear? N is equal to m into j minus a, minus is for retardation. Here try to understand, you will get more apparent, means exact apparent weight, effective weight, exact effective weight you will get when retardation is negative, when there is a retardation and lift is going upward. Now next case would be lift is going downward, but acceleration is upward. Now next case number fifth is retarding downward. Then what will happen? Downward. Everything will be same except one thing. Direction of moving lift is in which direction? So it is going downward. Downward is mg minus n will be equal to m, but acceleration is upward, m minus n is equal to m minus a plus mg. Yeah, minus n is equal to m is a constant, so z minus n, this equation we will get this equation minus n. There is a minus, when we will convert this minus into positive, this minus will become positive. G plus a. Here again you are getting what? Apparent weight more. apparent weight more. Apparent weight more. This is equal to uh, when lift was going upward, then equation was same as we have over here. Lift is going upward and direction is acceleration is also upward. So equation was n is equal to n a plus z, a plus z. Equation was same. Okay, that's why apparent weight will be more. Now let's do some question.